Bank, but I think if my face feels familiar, it's because I came from Project Tech4Dev over to the World Bank. So Lobo got tired of me, and you know, I had to. Just kidding. I've got to make fun of Lobo while he's here. But anyway, I'm at the World Bank, and I'm going to talk a little bit about what some of the projects that we're involved with. Within the World Bank, I'm in a group called DIME AI, so I'll give a short background on what that is. And then there are 3 projects I'd like to talk about that are at different levels of maturity and kind of showcase the variety of things that we do. So the first 2 are projects that I don't know about, but I know them at a very high level. So I'll do my best to answer any questions about them, but they're quite interesting. So I'm going to cover them in the first half, and then I'll spend the second half of the talk looking into what I do work on day to day, and that is a project called Zero Hunger AI. Okay, so within the World Bank, I am in a group called DIME, so that stands for Development Impact Evaluation. Within DIME, I am a part of a group called DIME AI. And so DIME AI is about 30 or 40 people who don't have it, you know, we're not necessarily economists like what you would think of at the World Bank. We're more specialized in AI and machine learning. There's about 30 or 40 of us. And then within my Hunger team, there's maybe 6 or 7 of us, maybe 8. We're growing, so it's hard to keep track. So I'm in a very small team in this massive organization that is the World Bank. You can think of DIME, you know, so impact evaluation is the name. But if you're familiar with agency fund, I think we have a lot of common views on the world. So if you're familiar with agency fund, you can, you know, I think it's safe to sort of say, okay, I know what agency fund does. I sort of get what DIME is trying to do. And then within DIME AI, you know, we're building AI tools that hopefully drive the mission of DIME, so help with impact. But really, we've got a broader mandate where we're really just trying to develop AI that has a positive social impact. And so those are the projects I'll talk about. Okay, so the first one is, we call it Impact AI. It's essentially AI for policymaking. So the scenario is you're a researcher or you're a policymaker. You need to make decisions about resource allocation or maybe research efforts, and you need to make those decisions with you know, factual knowledge. And so what do I mean by these decisions or these questions? So you can see over here on the right, do unconditional cash transfers improve food security? Right? This is a question you might have if you're a policymaker and you're trying to allocate resources for this stuff. Can teacher incentives improve student learning? Do hygiene interventions, or do they affect health outcomes? So these are questions about interventions, and you're interested in the outcomes that have happened. And you can use answers to those questions to help drive your future decisions. The challenge that exists, OpenAI is trying to solve this, but Impact AI is trying to solve this. The challenge that exists is a lot of times this high quality evidence is fragmented. You've either got to read a bunch of research papers, or you know, you've got to be deep sometimes in the fields of, you know, hand hygiene or keep up with the latest and greatest, and it's very difficult to do. So the solution is that, you know, they need a quick, reliable method of getting this information. And so that's, you know, this is what I'm going to talk about, is how we solve this. Hopefully this video comes up. So this is a video essentially, I guess, you know, we're sort of, this is an AI cohort. LLMs are very popular. So perhaps you can guess where this is going, right? Chatbots are really good at helping make sense of this. So the big reveal is that, yes, we are solving this with LLMs and chatbots. But there's sort of some interesting spins on it that are worth, that, you know, make it sort of interesting. So at a high level, this is the interface that we have, or that, you know, my team's built, my colleagues have built, and you chat with it as you would any other. So that was a bit quick, but someone essentially asked a question like I talked about before. This question is, what we look for, we hope for, are questions that have an intervention, and you want to know what the outcome is. And so once the person has typed the question, let me know if this is too fast or if it's really small, isn't it? Let me know if you want any clarity on this. I can see it better than most. So if something's not clear, just let me know. I can stop. And so once the question was asked, it says, do school feeding programs work better than cash transfers to improve school attendance? Of course, you know, these chatbots can go off and give you the answer, and they spout a bunch of information. So that's not quite new. That's fine. What our interface provides, though, are a couple of options that do make this a more interactive or a richer experience, or more focused experience than just using something like ChatGPT. So first, there are sources, and again, I know you can do. I worked on copy for a while, so I know you can get sources within these RAG implementations, but we try to add a bit more information around our sources to make them richer in how they are being presented. So not just sort of where we found it, but this was the entire study, this is where, and this is really how you can get more deeply into the weeds of what this source is trying to tell you. No, I didn't want to do that. There's still more to the video. So there's more to the video, and to me the cooler part is when someone wants a chart, right? So I'm going to pause it there, because now you've read the answer, you have an understanding of the sources, but what the chart provides you is this quantitative summary of what's happening. So this plot here is not taken from a paper. This is actually generated by the LLM, and it is a summary of the effect sizes that it found across those papers that it thought were relevant, right? So it's like not quite new research, but it's borderline. I mean, this is really summarizing things in a way that is really hard to do, even if you've read all these papers. So this particular answer, I don't know the details, but this particular answer is now telling you that these are sort of the effect sizes across these papers that we found. And so you can, if you know how to read these graphs, then you can sort of say, okay, yes, there is a positive effect size. And you can drill down to say, okay, this study had a larger effect size, so what was going on there? This study had a smaller effect size, so what was going on there? So it really helps you get deep into the details of what was going on across those answers. And this, so I'm not involved in this project, so a lot of the feelings I have are, my own, but I think this is a really, really cool, I'm amazed that they got this to work. Every time I talk to somebody about this, this is the part that jumps out at me. So it is, yes, it's effectively a chatbot that can give you rich sources of information and can also summarize it in ways that are really, really unique. And so how does it work? So I think the group, they really cringe when you just summarize it as a RAG pipeline, right? Because it's really much more than that. There's a lot of components going on. So you've got the user, and what they interact with is an orchestrator. So it's the orchestrator's job to both kind of say whether this is intent classification. So is this a question that I can even begin to answer, right? Or is this just something else? And once they classify it as something that they know about, then they try to identify that intervention and that outcome that is what the user is looking for. So that's what the first phase tries to do with this entity recognition and linking. Once they have some idea of that, then they spin off two parallel processes. One is a traditional RAG pipeline, and that RAG is populated by the research papers that the team has gathered, right? So that is probably very familiar to people that have worked with these systems. And I think that there's probably great stuff underneath the covers, but overall I think this is the RAG side of it. The data analysis side, though, is pretty cool because it's effectively, you could think of it as a search engine, a custom search engine that they built over these papers that can take your question and build a table, a quantitative table of what's happening. So this table will have different features like it'll sort of summarize the data in ways that are quantitative. So you've got a column for gender, right? So this particular study focused on women, or this particular study focused on men or something else. You might have a column for location. This particular study focused on South Asia or a different thing. So what they're able to do now is make this table that's very qualitative about how it answers your question. And that's what this data analysis pipeline does. And then they combine the results from these and they ask an LLM to synthesize the answer and they present that back to the user. So there's a lot of magic that happens under the covers. This is a decently big team. Couple things that may be relevant. I got a few minutes. A couple things that may be relevant for this audience that jump out at me was the PDF parsing. The guy that does the PDF parsing is based out of Delhi, I think, right? He's local. Our teams are spread out all over the world. There's a few of us here in India, And the guy that does the parsing happens to be here in India. And he spent quite a bit of time doing it. I think last I spoke with him, he felt like Mistral has been an effective tool for him. He complains about table parsing, so I know we dealt with that quite a bit. This is everybody's problem. And table parsing in economic literature can be even worse because you can have a table that, from a PDF perspective, is easy to extract. But the way the authors format the table, if you've ever read like these behavioral science papers, sometimes the way they format the table is difficult for humans to even understand. So he's dealing with not only PDF issues, but human issues. But that is a big part of what drives this. The other takeaway that may be relevant for an audience like this is the number of people that this team has devoted to making sure that data is good. So this is a team of about 20, 25 people. 30% of those, 7, 8 people, are just devoted to making sure the data is good. So these are people that do annotations over these research articles. These are people that look at responses of the LLM to make sure that the news articles they know about are cited and talked about correctly. But to me, this is one thing that people don't like to sort of admit or talk about or even know about with AI, and that is human intervention is really important to make these things work. And taking your data seriously is extremely important. So this is an overview of what happens. They've run a couple studies. So one is extraction accuracy. So they've got thousands of these articles that they've curated, lots and lots of effect sizes. And in one of the studies they've run, they find that Impact AI is able to extract this relevant information from papers often better than humans can. So that's a nice win. Impact AI beats humans at extracting evidence from RCTs. The other is a study that they did alongside, they've got Impact AI and how it works, and then they asked similar questions to GPT and got answers. And of course, Impact AI, no surprise that they win. It's a system devoted, completely designed for this, right? So it's no surprise that we won. But to me, what jumped out when I saw this graph, again, I'm not a part of the team, so this is my personal observation, is just the number of how low these popular models are in citing relevant sources. So that means that 30, 40% of the answers from GPT are coming from places that aren't RCTs, right? So maybe it's coming from other research. Maybe there's some hallucination, perhaps. But it could also be that GPT is relying on unreliable sources, like maybe news or blogs or things like this that haven't been vetted as strongly. So this is a result I know the team is very, very proud of. So that is Impact AI. It is a tool that is LLM-based, but it is designed to help policymakers be better at their jobs. The next one I will jump into is a thread we call social AI. The group has done a lot of work in offline or online hate speech detection and offline violence. So I think they call themselves social AI because they kind of straddle that sphere of social media and actual human social media. And so one of the projects that they're very proud of and they've spent a lot of time on and is a win for them is identifying hate speech online. So this is a survey from UNESCO that asked people how often they came across hate speech in their online life. And red means it happens a lot. Green means that never. They're living in this like utopia of Facebook that is just perfect. And most people are either in between or they're experiencing some level of unhealthy interactions more often than they think. So this, while social media was designed to connect us and make us happy, UNESCO found that it might not be doing that. And so this is dangerous because, I think this slide, this is just driving the point. I think most people know what's happening. This is dangerous because humans are delicate and, we can read things and we can actually act in the real world. So these are cases, sorry about the resolution, but these are cases from around the world of actual violent events that took place in part because of things that happened online. So, and I think, so this slide, I got these slides from one of my colleagues, but what I like about it is it's representative of the world. So I'm from the US, so this one happens to be the Capitol that, got stormed a few years ago. A lot of online stuff went into making that happen. This is a case from Europe. I'm not too familiar with it, but it comes from Europe. I think these two are from locally South Asia somewhere, and these I think are from African nations. So this isn't just a problem that's like localized to one place or one group, right? This kind of spilling over, if you will, happens around. So if we can solve it, that'd be great. So what do most people do now? There's moderation. You know, some of these social media platforms put a lot of money into trying to get people to moderate the content. The problem is it's reactive. People often just go to other platforms. It's really costly to scale because people can only read so many tweets or posts a day. And in some cases, I think when moderators' identity is revealed, it can hurt them. But there is evidence. So there's a lot of research to cite this. Unfortunately, I didn't have a chance to put the research here, but there is research that says that if you can complement positive messaging, you can drive some level of behavioral change. And it mitigates many of the limits of what I just said about moderators. But the challenge is you actually have to identify hate speech, right? And so hopefully we've got AI and ML people in the room, and big reveal, AI is pretty good at this. And so some of my colleagues in a paper, this is a paper, did I cite this paper? Yes, okay, so this is a paper from last year that some of my colleagues wrote. And this is an effort to do that identification. They managed to get their hands on 10 billion tweets from Nigeria over a 15-year period. That in and of itself blew my mind. So it took me a second to get past that, but they did it. And they, here's a plot of the tweets. So there's a bunch of retweets. There's a number of original records. This is, these are all in the millions, right? So you're looking at this over a 15-year period. And the users, I think that they got this from were actual active users. So this isn't just like, stale whatever accounts. There's some evidence that these are, real people spreading this messaging that's not very good. Great. So I've got all these tweets. What do I do? And the challenge with this type of data is twofold. One is just the scale. I mean, there's a lot of tweets. The other is that it's not from the US. So a lot of existing data sources are from the US. They're biased toward the type of language that happens there. And hate, right? Hate is a special thing. I could probably read one of these Nigerian tweets and not realize that it's hateful because I don't know the nuances of society there. So it's not even about the language, it's about the messaging. So they have all these tweets. It's in languages that a lot of models don't support. So they had to innovate, and this is kind of the probably the coolest slide, and the results are great. But this is one of the cooler slides. I'll take a second on it because the way they did it is pretty unique. So you have 10 billion tweets. None of them are annotated. It's not like Twitter came to you and said, hey, here's 10 billion tweets. Oh, and by the way, all 10 billion have a label of hate, not hate. This is a 5.8, this is a 4.8. No, Twitter's not, not that great. So you have to somehow make sense of this. And so what they did was they used this interesting kind of circle of upsampling. The other problem with the 10 billion tweets is not all of them are hate. There's a very small percentage that are hate, right? So there is some hope for society. You get 10 billion and there's a small percentage that are hate, right? But from a modeling perspective, that's difficult because you have this imbalanced data set. So what they did was they started by selecting, I think they started by randomly selecting some of these articles that they knew, and they got those annotated, maybe 1,000 at a time. And then they trained a model on the ones that they knew were hateful so that it starts to get a chance to know, okay, I kind of get what's hateful. They apply the model back to the data set so that it now comes up with an opinion of, okay, here's some that I think are hateful, and they use that judgment to then go off and get more annotated, right? And so you can use this cycle on the training set over and over and over again to kind of guide your annotations. And they found that after, I think, about 25 cycles of this, the model was actually pretty good. And when they were happy with it, it was a BERT model. So this is one of these models that kind of came before the big transformer explosion. So it worked. And they were able to find that they can detect hate speech at a much higher percentage than even ChatGPT can, right? Again, no surprise because it's trained on it. But this idea that I can iteratively move over all of this data that's a mess was actually pretty cool. Then some other researchers in my team took this and said, okay, wait a second, we can actually do something with this in real life. And so what they did was they ran a randomized control trial within Nigeria. And they've got their treatment and their control arms, and they have these users that I think they jump through a lot of hoops to identify, but they have certain users that they will, once they identify hate in their feed, they'll also feed them. Once they identify hate in the feed, they'll immediately give them this video of an influencer, a Nigerian influencer, saying, some sort of a peaceful message. I don't know the details of the message, but it, tries to offset the hate with a little bit of, peace. And then for the control feed, they just sort of leave the feed as it is. And what they found was that it was down 2.5% during the campaign. I think in both cohorts, the volume of hate posting was also down. And this was surprising that 3 months later, hate messaging was also still down. So this is a pretty cool, I thought, result. I think they're going to publish this soon, but it was a nice way of going from these models, right, that make great publications at popular ML conferences to actually having an impact on people's lives. So this was really nice. Okay, so now I'll move on to what everyone's been waiting for, and that is Zero Hunger AI. So this is a project that I work on. The goal is to predict food insecurity events. And what is food? So even before I started this, I kind of heard of food insecurity, but I didn't quite know what it was. So I think it's nice to take a second to step back. It's really having a lack of consistent access to nutritious food and an active life. And it's often determined by whether you can meet your dietary needs with the means that you have. So in some places, for example, you have to liquidate your assets, just to eat. And that is really the definition of food insecurity. I've seen various numbers on this. I took a conservative number of 130 million, but I've seen 200 plus in some places. It affects that many people around the world every year. And, everyone knows what it's like to be hungry. I think we've all been hungry before, right? So imagine that in an extended period, how stressful that can be. And for the kids, it's really bad because, it can stunt their growth and it creates a lot of stress during a time when they should be growing. The thing is, it's also pretty complex, right? You think of food insecurity, you think, oh, there's some famine in a country somewhere and it just happens. But it's actually pretty complicated. So there's things like conflict that can cause food insecurity. So if someone invades your neighborhood or invades your city, that can cause food insecurity. Poverty, of course, is there. You can have extreme weather. This can become like a cyclone that comes through. It can also be a slower moving thing like climate change. So if you're on an island and suddenly your land is started to be taken over by water, that hurts. And then food price shocks. So for example, in one of the side effects of the invasion of the Ukraine was that wheat prices went up. So even if you're living in maybe an African nation that Russia doesn't care about, you're importing wheat, and now all of a sudden you got problems, right? The standard response is humanitarian. So let's just throw money at the problem. But the challenge with that is it's often after it's too late, right? So they spent some wild amount of money in 2023 on trying to solve this problem, but it was often after the fact. And there's been a growing emphasis on trying to anticipate this, because when you can anticipate it and you get ahead of the problem, you can do other things or spend less money. And so again, big reveal, prevention needs prediction, right? And so now AI to the rescue, right? But how do we do this? So we'd like to move from this sort of red way of doing things down to the green, and hopefully AI can help us. So how does AI help us, right? So in order to use AI, first you need data, but then it often helps if you've got some target variable, like what am I chasing? And once you get this mix of things together, then the scientists all wake up and go, okay, I'll solve your problem. So how does this work from a hunger space? There happens to be an organization, or it's both an organization and it's a way of measuring things. It's called the Integrated Phase Classification System. And this is a 5-point scale that is given to localities, so countries, provinces, districts, that gives you a rating of how food secure or insecure you are. It's actually this analytical framework. So it's a framework and a courses that you can take to now become a quote-unquote expert in how to judge food insecurity in your area. And hopefully it's standardized enough that if I do it here in Bangalore and somebody else picks up a packet in whatever, Washington, D.C., that we'll come to the same conclusions based on what we see. So that's the idea. And it's estimated every few months. So they go back and forth between 3 and 4. There was a hole in the data thanks to, you know, when the Trump administration came in, they kind of shook up a lot of the NGO space. And one of the effects of that was we stopped getting judgments in some cases for certain areas on IPC. So there's some holes, but they try to make a judgment every few months. This also came in the news recently. I read the FT a lot, and they recently judged Palestine as being a 5, and that was big news. I think big news in part because just the Middle East gets a lot of coverage, but also because, you know, being judged a 5 is really such a catastrophe. There's sort of a this isn't a uniform distribution if you look at how things are. You know, it's heavy in the 2s and the 3s. To get to a 5, something really bad's got to happen. So it made, you know, that it happens rarely, but it does happen. So can we predict one of these numbers? That's the goal, right? Given a location, given information, can I predict one of these 5 numbers? And it turns out people have been thinking about this for quite some time. And there's lots of work suggesting that we actually can. And so the way, this is from a paper, this is a bit tough to read, but I can give anybody the reference if they want. But one of my colleagues is a co-author on this paper. And it's kind of served as a POC for not only, yes, you can do it, just like others have tried in the past, but we can use certain techniques to make it even better. And so this is really what we're basing kind of the foundation of our work today on, is what happened in this paper. So this is going to be a recurring theme over the next few slides. So what they did in this paper was they got IPC scores from 21 countries over about a 10-year period. And what they are looking for is places where it goes from a 2 to a 3 and remains at a 3, right? So 2 to 3 is special. So they broke it down into binary classification, but 2 to 3 is special because it means bad things are happening, but I still have time to kind of get in there and figure it out, right? So in the data, so yeah, we'll come back to this table. In the data, the way to read this is the number of food insecure events based on that 2 to 3 definition I just said. There's about 1,800 events across the 21 countries. And in addition, those experts, so in addition to identifying the situation, they make their own prediction, right? So I know what I'm talking about. Given that it's a 3 today, it's going to be a 4 tomorrow. It turns out that in this particular instance, they are about as good as flipping a coin. So the experts are really good at telling you what happens today, but like most humans, they're not so good at telling you what's going to happen 3 months from now. So this is kind of the bar that we're after. So it's 1,800 events. The experts were able to do this about 900 times. So we're looking to bump that number here. So again, I said that this has been tried before, and that these are kind of the reasons for the food insecurity, right? It's conflict, there's weather, there's climate shocks. So given that, you know, this existing knowledge, what a lot of people feel is, or the natural thing to try is, hey, if I got numbers around this stuff, if I get maybe satellite images, or I can somehow measure what's happening on the ground from an agricultural standpoint or weather standpoint, I can use that as a signal to be able to predict this stuff. So one of the first steps the co-author, you know, my colleagues did was to put together a model to see how well it did on this data. And here you see we're moving a little bit. So from 900 with some of these, what they call traditional features, we get up to 11. And if you combine the two, you get a small bump, but I think even traditional kind of realizes that maybe the experts aren't what they think. So you do get a small bump by combining this. So this is the expert column. This is if you just use those traditional features like NDVI or cropland use or population or violent events. You jump, and if you combine the two into the same model, you also get a small bump, right? So this is how it was done before, but how can we be even better? And the magic trick was, well, let's look at what people are talking about, right? Often, how can you do it? So in the previous work, they looked at Twitter, And in this case, they decided on news. And I think news is a good idea because it's readily available. I mean, they're pumping out news every day. It's structured. There's paragraphs, there's a title, there's an author, right? It's nice. It's not a tweet. And it's relatively reliable. Like there's, in most cases, some standards around this, even if you're, I know there's papers that we hate, but even there's some kind of standard usually. And the beauty is these NLP methods are mature enough now and accessible enough that they can kind of take advantage of this. So they were looking to see if they can do it. So they got a bunch of news articles from this organization called Factiva. They had about 11 million articles. And the goal was to figure out whether there are signals from these news articles that can help me be better at predicting food insecurity. The challenge is none of them are annotated. So again, usually organizations, this is starting to change, but a lot of times organizations don't just give you articles and say, oh yeah, this one's about food insecurity, right? Or yeah, you read these two and it's going to lead to food insecurity. That doesn't happen. So you get all these news articles and you have to figure out how to train it. And so this slide did not come out like I thought. So I'm going to try and go through it. But they essentially come up with this kind of novel method of figuring out what are factors around food insecurity. The beauty is, don't worry, we'll walk through all this. The beauty is they started with three concepts: famine insecurity, hunger crisis, and famine. They said, okay, these are three things that we know are related to food insecurity. Let's see how we can find related terms to that to now extend the set of concepts that we look for in news. So the first step was they used a technique that is probably common today, right? If you deal with vector databases, you turn these things into embeddings and you start to find similarities, right? So if I turn food insecurity into an embedding, hunger crisis, famine into an embedding, and then I also embed the document space, I can start to look at similarity and I can find similar things. And that turns out, of course that's gonna work. You're gonna get a ranking of everything, right? It's there, even though the terms that aren't relevant. So now I just take that massive list, I cut it off at somewhere and I say, okay, these top 100 are good, right? So now I've got 100 to work with. But sometimes with these similarities, you get, you may get sort of synonym-like things. You don't get deeper concepts. So in order to cover that gap, they use these models that are able to identify cause and effect in a corpus of text. So I wish this, I'm going to read from this gold one up here. Unfortunately, it's not visible there, but the sentence is, those living in dry land areas may suffer from loss of income and livelihood, famine, forced migration, and conflicts of war over scarce resources, right? So this is a wonderful passage. It includes this idea of famine, as well as what was kind of a cause or an effect of famine. So now I can look at those two pairs and I can say, okay, what's in the cause or what's in the effect portion of that sentence? Those are other words that may be relevant for what I want, right? So beyond just the similarity, I'm looking for cause and effect pairs. And it turns out not only does that work pretty well, but it can give you these interesting relationships between words. It can give you kind of ideas of what are stronger, what are potentially stronger drivers of food insecurity than others. Is that okay? So now we have this way of expanding this like crazy, and now they did a different step of contracting it by looking at some of the predictive performance over the keywords. So after this entire process, they nailed it down to 167 keywords. Right? I feel like if anybody's seen that Hitchhiker's Guide, the number 42 is there. This is sort of as, I guess, arbitrary as that. I don't know why they stuck with 167, but 167 is the magic number. And so now we can use these 167 to look for their appearance in news articles over time and use the counts of those appearances as an indicator of what's happening with that particular signal and whether that signal is going to drive food insecurity. I've got a graph about this later and I'll show it. Okay, so a technical presentation would not be complete without an equation. I know a lot of people feel they don't get their money's worth if they don't see it. So apologies for this slide, but this is essentially the makeup of how they form the machine learning problem. Right, so you create these counts of keywords across news articles. that are also associated with the location of the news article. So, December 4th, Bangalore rainfall was mentioned in 0.1% of articles, right? So that is now a feature in this model. And what this equation really just says is how we combine these different features. So there are a block, so in a feature are just columns you can think of in a matrix. So there's a bunch of columns that are devoted to the IPC score in the past. So what we're trying to predict is the IPC score today. So now we've got a bunch of columns of what the IPC score was in this location, whatever, the past year or two. Then you've got a bunch of columns that are devoted to those traditional signals that I mentioned. Traditional, whatever, population, NDVI. And not only do you have a bunch of them, but in some cases where those signals change, so things like population, well, population does change. Maybe the area of a country. I know some countries change, but let's pretend for a moment that the world is peaceful. You can agree that the area of a country is not going to change, right? So those get their own columns. And then for those ones that do change, they also get lagged columns as well. So this thing is starting to get big. And then finally at the end, we have columns for all those risk factors that I mentioned. So there's 167 of them for what I've recognized, and then there's more of them lagged. So this is at the month level, so I'll have 167 for this month. I have another 167 for the previous month, things like that. I'll also aggregate them at the higher level. So now there's columns for what was happening with those risk factors at a country and a problem. So this is a massive matrix. And the only way to describe it is with an equation. But just think this is a really there's a lot of columns in this matrix, and there's relatively fewer rows. So that's the problem that they're trying to solve. So now I've got this set up as a machine learning problem, and but does it work? Can I just throw a massive matrix at this and actually improve performance? So the drum roll and the wait for it. This is like the climax, right? So you gotta, let's make it last a second. Here we go. The conclusion is it does work. I probably wouldn't be talking, you probably knew that. It works, and it works really well. So now before, again, here's our table. We've got the number observed. We're looking to get to 1,800. The experts were a coin toss. You add in traditional, it bumps it a little bit. You add in news, and we get much closer. So if you just use news and nothing else, we were able to predict 1,400 of the 1,800 instances. But if you then add in a lot of the other features, you can get it up to about 1,700, which is a decent hit rate. And those are really encouraging results, encouraging enough that my project lead was able to convince Google to give us some money to build a team and to do it at scale. I'll be over just a couple more slides here. The other benefit, though, of this, and that's what we're really trying to tease out now, isn't just the ability to predict food insecurity. So I'll get to this in a second. This graph at the bottom, man, this is really tough. There's a patch that starts about there. Can you see it? It might be tough. So most of this graph is white, but these two bars here are yellow, and that indicates a place in this particular location where it went from the 2 to the 3. So these last few months, and you can see it with this blue bar. This blue bar is the actual ground truth of IPC. It goes from 2 and it jumps to 3. The other lines are what the non-news articles predicted. They just felt like nothing's going to change. But the news article realized, oh, no, there may be a change in here, and it's actually able to follow IPC. So this is one instance where we did really well. But what's even more interesting is that the news can operate as like a precursor to what's really happening on the field. So this is the vegetation index, and there was a pest infestation, right? So this vegetation index went down, and then it elevated, and I think that was a sign of some pest infestation that came. And if you just relied on that kind of signal from whatever, satellite or weather data, you would have seen the infestation maybe a little bit before the food insecurity event, but not too much more. But if you looked at what people were talking about, they were mentioning things like pest infestation long before the event happened. So there's a lot of value in news to kind of foresee events in the future. And so what we're hoping is that, you know, we can somehow split this out to talk more deeply about why food insecurity might be happening in different places. Right. So one more quick video. The other that we're trying to develop now is we're making a product out of this. So we've got one of the guys in the team is a front-end developer. So he's going to take these predictions and, you know, build a map that policymakers can use to see not only what's happening, but what may occur in their areas. This is an older mock-up. So these numbers aren't real, but this is an older mock-up of where we're going. I think in future versions, we'll have an additional panel that will start to tease out, okay, and I've heard a bunch of talk about conflict. I've heard a bunch of talk about, you know, whatever, weather shocks, to give policymakers an even deeper understanding of why the food insecurity may be happening. I think the other thing I didn't mention was what's sort of new for us. So initially there were 11 million articles. We now have 130, approaching 140 million articles. We get, I'd say, maybe 500,000 a month, something on that order. So we have a lot more data that we have to deal with. I am slowly thinking I might have to become a DBT engineer, and I'm thinking about all the Glyphic folks, or no, sorry, the Dalgo folks I used to watch. And we're also looking at different ways to modernize some of the NLP stuff. So using LLMs in the place of some of those like cause-effect models that we've used in the past. So that's it. Those 3 projects that we've got, Zero Hunger is the one that I'm interested in. So, yeah. Thanks. Yeah.
Like a basic question. So I was really intrigued by all the 3 product ideas, really good. And with respect to social AI, I had this question. So there might be like many ways to also find out the detection of these hate as such, right? So how was there any way where you could do this through like sarcasm hate detection?
Oh, like that.
Because there are even ways where you can like positively like throw hate or something through something. Was there a way which would be?
Well, the short is I don't know, but I think I remember in the paper they did mention the importance of finding annotators who were local, who were Nigerian based, and I don't know what other factors they looked for in their annotators, but that was very important for them so that they could sort of tease out perhaps whether this is like coded hate or like, you know, tangential hate. So I know they went through a big effort to get that. But yeah, as far as whether sarcasm does it or not, I'm not sure. This, I guess, yeah, if you're really curious, find me, because that work actually has a publication that really details this methodology. And you can't see it here, but I can point you to it.
Yeah.
How much of the AI projects, you know, the AI problem can you adapt it for anything else apart from
Yeah, so I think that's what we're grappling. I mean, we're grappling with. Grappling is the wrong word because it often means that, you know, you can't figure it out. But we are thinking that this can fit. There's like a broader kind of theory, movement around like shock prediction or event prediction. And we're feeling that this can fit in the broader ecosystem and stuff like that. That's a vague answer. I think personally I'm more interested in what these indicators may mean for other factors that are happening in the area. So one thing that, you know, a guy brought up to me recently was whether he can start to use news articles to inform some of the hate speech work that was happening, right? So I don't know if those indicators would be the same as with, you know, maybe a few of the signals can mask over to jump over into the hate speech stuff, but that could be one area where just knowing what people are talking about would help.
With regards to the news articles, I was curious as to if there's a pre-approved list of publications which this is pulling from, and I asked that because nowadays we also have AI-generated news content or AI-generated summaries.
I'm really worried about
something
this.
to sort of speak to the veracity of the news articles that you're pulling from?
So we work with a commercial organization. So Factiva is one organization that provides news articles. We've moved to another organization called, it's called News API, but it's from a company called Event Registry. And so we, sort of vetted them, but we do trust their process in what they pull. They give us a lot of information about these articles, including, sources. In some cases, they do give us locations and concepts like this. So that's one way to sort of filter out, right? So if there's a source that we identify that they like, but we don't like, we can vet out that way. They also classify articles as news, blogs, and press releases. So we're really kind of watching, like, which one of these are peaking. Like, if blogs start peaking, maybe maybe it's a sign that people are writing. I don't know what they're. I sort of asked them about this, but I don't have a solid answer. How they're going to start dealing with AI written articles. I'm really worried about this because it's just going to pump more maybe junk. They also do. Sometimes you can run an article and then different news agencies run it as well. They do help us sort of identify which ones are duplicates. So all this sort of helps us. Yeah.
Just following up to that, so news articles that you do trust or trustless, you kind of do a weightage to them, higher rating, or just a binary thing?
Not yet, but I think if this is one of the, we use Notion, and I think one of the Notion tickets is somewhere like, try and figure out if we can start weighting some of the sources. Right now I don't know the best way of doing it. I mean, of course, if it's the BBC versus, Bob's blog, that I can probably judge in my head. But for some of the better sources, I'm not quite sure how we're going to differentiate those beyond human opinion. That's sort of, I think, one of the big challenges. Maybe we just have to look at enough of those articles to sort of know that this is a reliable source in this area. But differentiating that even when this mess of articles is important for us.
Is there someone who checks the biases as well?
In the news articles? No. In the news articles or in, so no. We don't. I think for now, we're going to look at like summary stats to try and tease some of this out. It would be nice in the long run if we could hire some annotators. I don't control the budget, so I don't know. But there's also another side of this, and that is I don't know if this is true, but I'm really starting to wonder if there's just so much data that sometimes it takes care of itself. I don't know how much that'll work, but there is quite a bit of data here, and I'm really wondering how much matters and how much room for error there is, say, in our tagging process, and you can still get decent results out the other end.
I'm just curious with respect to the data that we have on the countries and the poverty index that is shown in the country, right? Different countries. Sorry, not the poverty, the hunger index that is.
This one.
Yeah. I'm just wondering, does the amount of data or the number of news articles, have you seen any correlation in that and this? Like, for example, if there is more news from a certain, or we have more data from a certain country, then that's contributing to maybe, I don't know, if that's also resulting in lower score for that country or a higher score. Are there ways to kind of mitigate that, or can that happen?
That can certainly happen. I mean, so there's a few things that affect it. So one are some of these places where there's not a lot. So I think Zambia and like Burkina Faso, right? There's just not a lot of these events. So that's one thing that's challenging sometimes. I don't know. I don't know. So this is just one table from the paper. The paper had a bigger graph that actually showed not only all these countries, but the RMSE, when they treated this like a regression problem. They showed the RMSE and the range that's over it. I know they did a bunch of ablations. I'd have to look back at the appendix to see if they did a study around just the number of articles versus the predictive power. I'm not sure. I do know, though, I mean, so all of this is normalized. So when you, like, if famine is mentioned, I don't take the raw number, like, I don't take the raw 100. I always normalize it by the number of articles that appeared in that area. So I'm just wondering out loud whether that kind of, from like a modeling perspective, kind of gets rid of, you know, them talking more. But I don't know, it could mean that now the features are a little more compact because my percentages are more realistic. They're not driven by these, you know, either small data or waves of different things. Anyway, it's a good question. I don't know. I'd have to look back at the paper and see if they did the appellation. Yeah.
For the policy part, the database of that, knowledge base of that is just policy documents or something more as well?
This one?
Yeah.
I think my understanding is it's just RCTs. So not even policy documents in general. This is research that included an RCT. It's like very, very highly focused on that.
Is that a part of parliament?
Uh,
Certain other studies which could speak to the issue which are not RCTs?
Yeah, I don't know why they made that choice. I don't know that. It might be the target audience, right? That really only wanted what they considered factual information. Yeah, something like that. In this one, yeah. At this stage. So this stage is. So if I got rid of this completely, then I think this would be a traditional RAG pipeline. I don't know how much experimentation they've done with the chunking and things like this, or the way they, I don't know, or how they break up the documents, or even, you know, what they add into the prompt before they send it all back. But the vector DB stuff happens there. Yeah, I don't know. I mean, I think since they are kind of really hyper-focused on these RCTs and research studies, the formatting of the documents isn't nearly as wild as as the government sets that we were looking at. Right? You can, right, there's 5 or 6 different journal formats, and you can kind of lean on that. But, you know, the challenges of non-text are still the same. You know, how do I get this how do I extract this table? How do I extract meaningful information from the table? And figures, right? Here's an image. What does it mean? Where in the text is talking about this? So I kind of get a sense for what it means. Those are some of the bigger challenges, I think, with these research articles.
Quick question.
Yeah.
The last one thing that showed us, how is that being received in these different countries?
Which one?
Yeah.
Oh, this one. No, we haven't shown this in any countries yet. This is really it's internal, not internal to the sense that, like, you can't, you know, I don't have to kill you because you've seen it, but it's more internal just for us to get a sense for what we like. Our goal is to have a working version of this by the end. When I say working, a version of this that is actually making predictions based on those 130 million or whatever subset is relevant of those articles. And those predictions being fed into these colors. And then maybe some stuff on the side about, you know, what are the model weights, or why do we think these colors are happening in this area, some indication of why. So our goal is to have kind of a mock-up of that by the end of the month, then do some user testing in Jan-Feb, and then have something that we feel confident in by the spring. Because in the spring, the World Bank has this big meeting where everybody comes to Washington, and, you know, and so hopefully we can have a little booth and showcase something.
The intended end users World Bank.
I think the first set of users will be heavily like World Bank economists or policymakers or people that we work with. I think that's really our first target audience. But I do think we have goals, at least my understanding is we have goals of making this a publicly consumable tool. So hopefully at some point, our Google grant is for about 2 years, which will run us through next year, and then I think half of the one after. And hopefully by the end of the grant, there's a website that I could point people to and say, hey, go look and see if your neighborhood's food insecure. I was really, so as an aside to that, as we were looking into this, I was really surprised that Maharashtra is considered food insecure by some standards. Maybe that's obvious to some people, but as somebody who lived in Bombay, it doesn't have a lot of exposure to the rest of the state. That was a surprise. So this tool could maybe change your mind about your locality or what's happening around you.